Hey, this is Mr. K, and today we're going to go over the product rule for derivatives. So you'll see the product rule for derivatives written many different ways. One way that you'll see it might be like this, only they might use the letters U and V. I like using F and G. But the d dx just means you're taking the derivative of, and then what are you taking the derivative of? The product, or the multiplication of function f times g. And so what that's going to equal is it's going to equal your f times the derivative of g with respect to x plus g times the derivative of f with respect to x. A lot of times what you'll hear is it's going to be the first times the derivative of the second plus the second times the derivative of the first. So if you'd rather write it out that way, that works just fine too. So an example of something like this would be if I have, let's say I have function 2x squared plus 3x. Let's say that I'm multiplying that by 5x minus 12. You could go through and FOIL this all out and multiply everything out and combine like terms and all that jazz, but it might be easier just to apply the product rule. So the product rule is I'm going to take my, so let's say that this is our function f of x. So what I'm going to do to find my f prime of x is you can think of these as two separate equations. Like if you're using the letters u and v, let's say that this is my u or my first, and let's say that this is my v or my second equation. So what I can do is that my derivative would be the first, so 2x squared plus 3x, times the derivative of the second, which would be times 5. And then I'm going to add to that the second, so my 5x minus 12, times the derivative of my first. And so now if we're using the power rule, you'd have 2 times 2, which is 4. So this will just be 4x to the 1, or just 4x, and then plus 3. And so here you see my first times the derivative of the second, so like we'll call that second prime, and then here's my second equation, and then times the derivative of the first. And so if you wanted to go through and combine like terms, we could do that. Some teachers require it, some don't. So if I distribute here, I'm going to have 10x squared plus 15x. Here, if I FOIL this out, I'm going to get 20x squared. That'll be plus 15x minus 48x, which is going to be minus 33x, and then that'll be minus 36. So if I want to combine everything, I'm going to get, so it'll be 30x squared, and then if I have plus 15 minus 33, that's going to be plus, or excuse me, minus 18x, and then minus 36. And so now I can show you that this derivative right here, by using the product rule, is going to be the same exact thing as if you FOIL this whole thing out and then just take the derivative of that. So if I rewrite this, so let's go back to my original. So it's 2x squared plus 3x times 5x minus 12. If I now FOIL this all out, I'm going to get 10x to the third. I'll have minus 24x squared of plus 15x squared. And then I'll have minus 36x. And so now if I can combine my like terms here, I'm going to get 10x to the third minus, this will be 9x squared, and then, oh, I know I have an x there. this should be 36x. And so then minus 36x. And so now if this is our f of x, our derivative, if we apply the power rule, we're going to have 30x squared minus 18x minus 36, which is exactly what we have up above. So that shows you that it's the same thing. It's going to be a faster way, a more efficient method of finding the derivative of two smaller functions that are being multiplied together. Thanks so much. Have a great day.